Welcome everybody. We'll just give it another 20-30 seconds as all of our attendees slowly join the webinar. We'll be with you in 15 to 20 seconds. Okay, welcome everybody. Good afternoon, good morning, good evening, wherever you're joining us from. Thank you once again for joining another one of Midstream's webinar Wednesdays. Today is all about mitigating the effects of glare for external floodlights, an extremely important topic for all of the sectors that we work in, and an issue that everybody who's joining today, I'm sure, understands is a big part of the role that we play. Just before we get going and we kick off the session, a little bit of webinar protocol for anybody who maybe has not joined one of our sessions before. You are all muted. However, you do have the ability to chat and type questions to us via the Zoom platform, both on desktop and mobile. So please make sure that if you do have any questions, you put them into the Q&A section of the webinar. That means we can get to them in the correct order when you actually ask the questions, as well as give us the ability to track the questions to get back to you post the session if it's something that we either can't answer or we don't have time to today. You will all receive a follow-up email. You'll get a link to watch the recording, links to any of the resources we mentioned, links to upcoming webinars. So watch out for that follow-up email over the 24 hours, 48 hours that follow the session. There is also a survey that will pop up at the end of the webinar. It actually asks you to do that in Zoom and puts it into a different tab on your screen. We really appreciate everybody filling the surveys in. It's great feedback. It helps us plan our next sessions as we go along. Like I said, Q&A questions in the Q&A box. So today's agenda, we'll do some very quick introductions. If you joined us before, you'll know both myself and Paolo, who is presenting the session as well today, as well as I'll do a very quick 60-second introduction to Midstream, as you do have some new people once again joining on the webinar who haven't actually been with us before. The session then, as I said, is based around mitigating the effects of glare, and Paolo will run through a number of concepts, a number of slides, before flipping straight into DIAlux, where he'll be giving some demonstrations on how we design our solutions using the software to mitigate the effects of glare as best we can. There are two polls. Again, this will show up on your screen. So when they come up, it'd be great if you could get involved both on mobile and on desktop and give us some information as we get to those sections. And Q&A we'll do throughout as well as at the end. So pop your questions in the Q&A box. We'll get to them as we can, and we'll come back to them at the end of the session. So, quick introduction. My name is Michael Short. I'm head of marketing here at Midstream Lighting. I've got over 10 years of experience in marketing, having worked in industries that go from home automation technology to automotive, and I'm here looking after Midstream's marketing across all our sectors as we grow and build the company. And joining us today is Paolo Corno. Paolo, why don't you introduce yourself?
Hello everyone, I'm Paolo Corno. I'm the Technical Director here at Midstream Lighting, and I've been working on the LED lighting industry for the past 10 years. I look after both the lighting design of the large infrastructures or sports facilities, as well as the product development of our production line.
Thanks, Paolo. Okay, so very quickly, who are Midstream Lighting? If you don't know us because you're joining, because you've come via our social channels or you've had the email passed to you by our peers, we're a full cycle turnkey specialist manufacturer of LED floodlighting systems and solutions. And we count ourselves as design experts. It's part of the work that we do. We don't just manufacture the product, we put a lot of our time and effort into the design of these solutions. And we're experts in the area we work in. So we focus on airports, sports, maritime, and horticulture. And we've been doing this since 2010. We manufacture our products right here in the UK, as well as in Romania. So we keep our quality exceptionally high, and we can also ship extremely quickly to all of our solutions and projects all over the world. What sets us apart? Well, our products are extremely unique. We use proprietary optics, and they're designed specifically for the applications they're intended for. So when I say specifically, if it's the aviation industry, we have built and manufactured products, designed products to suit apron lighting. Everything we do is built specifically for the applications they are intended. We have a fantastic R&D facility, which is where Paolo is based in Italy. It's our technical office based in Milan, and the team over there are continuing to research and develop and build and pioneer LED lighting technology. We see ourselves as specialists, and that's because of the fact that everything we do is built for the applications they're intended. So we are not generalists. We only focus on the sectors and markets that we build our products for. We offer a number of services, whether it's manufacturing of the products, but it's also things like lighting design. We can support on rebates, incentives, training, education, consulting, and financing. Again, specifically in the markets that we work in. And our aim is not just to be a manufacturer, it's to bring sessions such as this to build knowledge and share knowledge within the industries, across our peers, our clients, because we want to be seen as bringing the sector and educating the sector forward, which is why we're continuing to do these webinars. There's lots more information about who we are on midstreamlighting.com, so you can definitely head over there after, head to our knowledge center where you'll find some really great information. But enough about Midstream Lighting from me. I'm going to hand it straight over to Paolo now, who's going to kick off this new session on mitigating the effects of glare. Paolo, over to you, mate.
Thank you, Michael. Actually, let me get back control of the presentation. Okay, so today we're going to be talking about glare, which is one of the most annoying aspects of artificial lighting. We're going to keep the discussion a little bit at the basic level. We're not going to get deep into, let's say, the math aspects of glare calculations, but we'll see what glare is, just give an explanation of how glare is calculated, and then we'll see some examples in real life using DIAlux. First of all, what exactly is glare? As defined by IAS, glare is a discomfort or a loss in visual performance or visibility caused by luminances within the visual field, which are sufficiently greater than the luminance to which your eyes are adapted to. Which, in simple words, it means that glare is a contrast of lighting. So, for example, the same luminaire can be very glary in a very dark environment, or absolutely unnoticeable if it's surrounded by another 100 luminaires of the same type. Glare is also something which is subjective, because it's influenced by the viewer's age, the iris color, and just the individual sensitivity to light. So again, this is not a parameter like a lux or a kilo, but it's a human sensation. What can glare actually mean in an infrastructure or a sports facility? Anyway, how does glare affect things in real life? Because somebody might think, yeah, well, glare is just something that annoys me. But what happens is it has impacts both on safety and on performance. Regarding safety, well, you have employees working on the ground, whether it is an airport or a port that we're looking at, and you reduce the possibility for people to see objects and to read small things due to the glare. So this, of course, affects the safety of the working environment. It greatly affects pilots of airlines when navigating through the taxiways in an airport. There are many reported incidents where airplanes, due to the glare caused to the pilot, have missed the turns onto their taxiways and caused big drive around an apron area. This might seem like a small thing, but in an airport operation, this is a major problem, because it will basically have to reset all the queuing system of the planes, and it will cost thousands of euros or dollars, whatever it happens. Another category which is highly affected by glare is machinery operators, especially in the port sector or any logistics sector. Again, there are many reports of incidents caused by glare where, for example, stratocarriers drivers or reach stackers, they just miss an object and hit a container or cause accidents between each other. And I mean, they can be deadly when operating such big machinery. Glare also affects passengers, and passengers are often brought to the plane, especially low-cost airlines, by just walking onto the apron. And the last thing you want to have on an airport is to have 100 people with the lower visibility on a live apron. And last but not the least, the air traffic control personnel, it's greatly affected by glare. This is because they're usually the first ones to complain about glare in airports. Because air traffic control personnel sits in a high tower and have to have perfect visibility across all the airport. With very glary installations like the one we see here in the picture, you basically lose the visibility of what's behind it. Because if what's behind the glare installation does not have enough luminance, it will be visible for you. So in many airports, there are issues related to this type of glare. Then let's go on to the performance aspects caused by glare, which is a lot related to the sports world. There have been instances in the past of football goalies complaining that they've been glared by floodlights and missed the opportunity to catch a penalty. And even though this might be an excuse many times, it's actually a very real problem. We can actually just jump back to the previous slide here. This is an example from the Sapporo Dome in Japan, where the last Rugby World Cup was played. And you can see how glary the installation on the side of the field is. And this is again due to the differences between having very bright luminous sources with a completely dark background, because the roof is not lit. And there have been many complaints about players, but also for TV cameras, because when a TV camera is filming a sporting event, maybe it has to move quickly from one side of the other of the field, and if there is a high contrast, a high difference in the luminance, it will take time to readjust the image. So also the TV audience is affected by it. And again, last in this list is the spectators. I'm sure all of you have attended a sport game where you had just one floodlight pointing at your face and just prevent you from actually watching the game well. Let's go on to our first poll. To you, Mike.
Thanks, Paolo. And yes, I've definitely been at football matches and had, lights glaring in my face. It is a nightmare. And by the way, spectators are definitely not last on the list. They're the most important when it comes to venues. Okay, so I'm going to fire up the poll. And this is actually a pretty general question to everybody. So if you're looking away, you're on your phone, maybe you're working on a different screen on your desk, please look back, and if you can answer the two questions in this poll, it would be fantastic. So the first is, has glare ever been reported as an issue to you at your location or facility? So this is both to if you are the end user here, or actually you're a designer, you're an architect, because ultimately you are still probably getting the reports back to you about glare. So have you ever been reported? And if it has, are you still having issues with glare on site or on that project? Because we know that it can be very difficult to get around to fixing the issues of glare, because in some cases, it might be the fact you have to rip a whole old lighting system out and replace it. So the two questions, and you have to answer them both to be able to submit your answers. Has glare ever been reported to you or been an issue on your site? So, all of our people hopefully can give us an answer on that. And if you have answered yes, is it still a problem that you're encountering? So we're almost up to 70% voted. I'll give everybody just another 5-10 seconds to get their votes in. And all the panelists can actually also vote today as well. So everybody can take a vote. Fantastic. I'm going to end the poll and share the results on screen. Okay, so overwhelmingly 55% of the people have had a report of glare or an issue of glare on sites, which, Paolo, is that something you expected? I assume this is something we probably come across quite regularly.
Yes, I mean, basically every time we visit a place like a port or an airport, there is an issue with glare. It's something which is extremely common.
Okay. And then it looks like 30% of those people who answered yes are still having projects. Really interesting. We know that it's a tricky situation to rectify and does require the use of expert support from outside the actual project itself. So again, it doesn't surprise us that some of these issues have potentially not been fixed yet. So thank you very much, everybody, for your participation. I'm going to stop sharing the results, and Paolo, right back over to you.
Thank you, Michael. So we've now seen a little bit what glare is. Now let's start to look into glare calculations on our lighting design. Let's start with understanding the limits of glare calculation. Evaluating glare, it's really not simple. It is simple to run the formulas provided and run the software, but it's not simple at all to turn that number into a real sensation. Imagine you have to describe with a number how hungry I am after one day of not eating. And that might vary a lot from one person to another. So the results that we can get on the software are not always 100% reliable in terms of what the feedback from the personnel would be. But I mean, at least it gives us something to start with. There's a number of assumptions made in the glare calculations, which sometimes can really make the calculation inaccurate. For example, when dealing with point emitting sources like LEDs, the value of the luminance of the light source is it's always an assumption because you're actually at little dots emitting light, not the entire surface. So, for example, if you have a lot of low power LEDs, then the assumption is close to reality because your area is completely filled with light emitting surfaces. But when you have clusters of LEDs, like COBs, for example, in like the luminaire and the image here, you will be considering the light emitting surface as the whole bottom part of the luminaire, while actually the light is concentrated only on those lenses. So again, this is just to make sure we all understand that glare calculation isn't something perfect, but it could be something good to, for example, compare between one solution or another, or even when doing a lighting design to improve, because anyway, a lower value with the same luminaires will mean a lower glare. Now let's get into how glare is actually calculated. Well, since our sectors are all involving outdoor scenarios, we'll be using the GR, the glare rating. Well, I'll just put the formula here, not because we'll be manually doing it, but it's just to understand what the basic concept behind this glare rating is. As you see, the formula here revolves around a ratio between two main values. The LVL, which is the veiling luminance caused by the artificial lighting that we are evaluating. So it is the sum of all the veiling luminances produced by each luminaire that I'm going to be placing in my outdoor scenario. Veiling luminance is it's the luminance superimposed onto the human retina, and it's actually what's called disabling glare. And then the other factor here is the LVE, which is the veiling luminance of the environment, which is basically what's going to be behind or around the lighting system that I'm evaluating. And of course, you can imagine from the formula that the bigger this distance here, so the bigger the contrast between my background and my lighting is, the higher my glare rating will be. There are other methods you probably heard of for glare calculations. One would be the luminous intensity calculation points, which is sometimes used as a sole parameter in lighting calculations, which I deem to be very incorrect, because this would only take into account the luminance of the light source from a certain point, which it's good only to compare results while you're doing the work, but it does not give you a general number, a general idea of what the glare would be. Then there's a threshold increment, or TI, which is expressed in percentage. That is a parameter used in roadway lighting, which is, let's say, it's based on very similar concept of the GR, but it's all based on the idea of having obstacle about, I think it's 85 meters away from you on the road. Anyway, it takes into account different parameters. And then there's the last one is the UGR, the Unified Glare Rating, which is often confused with GR, but that is actually a standardized calculation method, which is only applicable to indoor environments. So it's not something we'll be looking at.
Paolo, can I ask you a quick question? It's come in.
Yes.
I think it's relevant to the calculation. Are there any differences at this point between COB and SMD technologies?
I'm not sure I understand correctly, but let's say that, well, this COB technology is generally, even if you get the same GR in an environment and you compare it, usually the feedback is that the COB is more glary, just because you have a higher concentration of luminance into a smaller area. So, okay. But I mean, there's many differences between COB and just normal SMD, but on the glare part, I think this would be the biggest difference. Just the concentration of light into a small surface.
Okay, great. And then what is the meaning of veiling?
Yeah, that's not a very simple concept, but again, the veiling luminance, it's the luminance that hits your retina. It's I don't know how to explain it very well, but it's that component of the luminance which will disturb your eyes. This, again, I wanted to keep this a little bit more on a higher level, because glare and especially all these parameters, it's something, if you go deep into it, it's going to be a very complex conversation, but we'll be happy to send you some more detailed information.
No problem. And guys, with all these questions that you're putting in, can we make sure we put them into the Q&A section? It means we can actually follow up afterwards and get back to you directly, or we can link to things that we talk about. So yeah, if you drop it in there, it'll help us greatly actually work with you both during and post the session. Paolo, back to you, mate.
Yeah. All right. Actually, I just saw another one coming in. Does the color temperature of the lamp source will have any effect on glare? No, it does not. That is something just subjective, but in terms of number, it just will not affect. Let's look a little bit on, before we jump into the practical part on DIAlux. So what can I do to my product to make it less glary? Because yes, a big part of the glare is the design itself, the scenario, but of course, equally important is the product itself. So we identify two key parameters that a product has to have in order to reduce the glare as much as possible. First of all, the choice of the type of optic. We believe in refraction optics and asymmetric optics for all the possible applications. The way by using optic matrix like this, not only we extend the emitting surface, the reducing the luminance of the source, but we are also able to, by giving this asymmetric shape, to reduce the peaks of the light in terms of candles per kilolumen, the reducing, again, the veiling luminance in the hotspots. So it gives a smoother, more uniform type of lighting, and at the same time, it lowers your glare value. We will see a comparison between the use of an asymmetric optic and a symmetric optic with the same flux on a scenario shortly. The other solution is mechanical shielding. So when due to the geometrics of an area, it is impossible to use asymmetric optics, refraction optics, then mechanical shielding becomes a very important part of reducing the glare. Well, it not only reduces the glare, it also helps solve other solutions like light pollution, upspill, and other things. But regarding the glare, this will help us hide the light source from different viewpoints along the area we're calculating, though reducing the glare ratio a lot. Let's actually switch on to the DIAlux now and see a little bit in detail what we discussed now. Oh, actually I have the wrong one open. Let me open up this first scenario. My computer is not, okay, great. For those of you who have participated to the first seminar, you'll maybe recognize this area here. And actually, for those of you who participated, you have received this file following the webinar, so you can just, you can try to do the calculation along with us. Otherwise, again, after this webinar, you will receive these files, so you can play around and do some trials yourself. So anyway, this area that we're going to be looking at is was a simple 2 aircraft stand apron area, which we had run the calculation with our Titan 560 luminaires, placed at 30 meters height. Well, the goal of the older webinar was to provide ICAO compliant lighting for both the aircraft stands, the circulation road, and the other apron areas. Right now, what we wanted to do is evaluate the glare rating of such installation. Oh, by the way, I skipped a step. In order to, of course, understand what value of glare is acceptable, you can always refer to the same regulations that give you the correct light levels and uniformity levels. They also state what is the maximum glare rating level accepted for each type of task. Generally, a value of 50 GR is what's considered always below an acceptable level. For example, for aircraft aprons, the limit is set at 50. So how do we calculate it on the software itself? We're going to switch to the 2D view. We're going to be using GR observers. So we're going to go onto the object tab, go down to calculation points, and with the drag and drop, we're going to put a GR observer onto our simulation, onto our drawing. How do we place these GR observers? GR observers have to be placed where the task is carried out. So for example, in the case of an aircraft stand, we're going to have 2 types of operators on the field here. We're going to have ground staff, and we're going to have, again, passengers, and we're going to have pilots. So not only they go into different places, but they also sit at different heights. So what we did here is we've added by drag and dropping a bunch of points, a grid of points. Of course, the more points you put, the more dense the grid is, the more accurate the calculation will be. But glare calculation also takes a little bit of time on DIAlux. So for example, here we included it just on key parts. So for regarding the ground crew, we have placed glare calculation points at the height of 1.5 meters. We have left all the other parameters to the default according to EN 464-2, which is the normative we were looking at a second ago. And we have displaced the points along this grid. Now, we also want to simulate the glare cost to the pilot. And so we have replicated the same grid at the height of 4.5 meters. Of course, you will have to go look at what class of apron we're looking at, see what the maximum cockpit height acceptable it is there, and use that height. Here is just an estimation, 4.5 meters should be something like Airbus A330. And here the most important values are going to be the ones along the center line, because this is where the pilot will actually sit. So it's going to travel from the taxiway into the standing area. And we need to make sure that in none of these points he's glared. Also, this calculation can be run on the taxiways as well. So let's see the results of our simulation. I'm going to go into the output tab, and we're going to our GR observers result overview. This is going to give us all the points that we've plotted. So let's look at the numbers. Regarding the ground crew, we see that the results are always below 41 glare, which is an excellent value. So we know that for ground crew, we will not provide any significant glare. And for the pilot also, we have very similar values with a peak of 42 of GR. So again, this is an extremely acceptable value. But of course, this is a 30-meter installation. It's easy. Let's try to make things a little bit harder. Let's reduce the height of our mast from 30 meters to 18 meters, just to see what effect that is going to have on the glare rating. You can see how now that the towers are much shorter than before. So you would expect, of course, a change in the glare, because especially for the pilot, now the distance between the eyes of the pilot and the luminaires is basically cut to half. So I've pre-run the simulation. Let's compare the results. You can see that regarding the ground crew, we have had a significant raise of the glare rating, even though we get to level 49, which is perfectly acceptable for the normative. But when it comes down to the pilot, using such a lower height for the mast will give us numbers up to 53 GR, which in this case, it would not be acceptable. So here we would have two choices: either go back to increase the height again, or if, for example, we're not allowed to increase the height because that's a fixed infrastructure, or maybe there is OLS limitations in the area, what we can do is go look at the details of this particular observer. Right now, it's just the highest one, which is the fourth down from the list. We will go and select it. And we can check. This is the summary of the glare rating from each directions. So we can see that the observer, which is placed number 13, which is placed here, gets the maximum glare from an angle of 240 degrees. So we know that the responsible for this peak of glare is this very mast. So, for example, if in this case we had to live with 18 meters, we couldn't do anything, what we would try to do is split our lighting arrangement, and then with fine adjustments, try to avoid the light, the peak intensity of our luminaires to fall within the hotspot area. For example, here we would try to rotate them away from any direction pointing towards the center line. And of course, it's going to be a lot of trial and error work, but by doing this and reducing the tilt as much as we can, we'll be able to lower this level below 50. Let's say that something I escaped actually. It's by reducing the height of the mast, we had to increase the tilt of the luminaires. And that is what made the glare worse. It's not just the height difference, but it's the fact that now my luminaire, it's not sitting flat like it used to be, but it's tilted at a 20 or 25 degree angle, making the light source much more visible for every observer, though increasing the glare rating. let's now look at something else. We have seen before that the glare rating is a result of not only the light emitted by our luminaires, but also from the contrast to the background. Right now, we have evaluated the glare of this area by using a ground element, which is exactly the same size of the area that we are evaluating. Let's look at what would happen if we increase the area, the base ground element area, and make it about 10 times bigger. So we have prepared an extended ground element area. So here we have the same exact configuration. So our two aircraft stands, we have the same exact luminaires, the same GR points. The only thing that changes is that we have increased our calculation space. Let's see what effect is this going to have onto our results. You can see that this change has dramatically increased the GR values on our scene. Now we go way past 70. We got the highest point of 76, which would be an unbearable glare. This is not, let's say, a realistic result. This is the result of using a large area, because you would compare something which is well lit here to an environment which, especially when it's a computer generated environment, which is completely dark. So making this mistake will give you completely fake GR results. When you have to evaluate the GR of an area, you have to reduce the surface to the one of the tasks that you are evaluating. If you're using a very large surface, in reality, this would look very different, because you will have other stands with lights, a terminal with lit up windows, a city in the background. So all the elements, which again, going back to that formula we have seen, will reduce the ratio between the veiling luminance made by these luminaires and the background veiling luminance. So my suggestion is, when you do GR rating calculations, always try to stick to just the task area that you're doing and reduce the ground element as much as you can. So you're gonna have more accurate results.
Paolo, do you have to account for upwards glare, which would, light overspill potentially for, let's say, pilots who might be flying in? Is that part of a consideration in this process?
It's not part of the glare itself. That would be the ULR, the upward light ratio, which in many countries is regulated. So, for example, if you're, let's say, the most accurate normative regarding this aspect is the Australian, the MOS 139, I think it is, which will state that if you're less than 300 meters away from a taxiway, from a runway, your ULR has to be 0. Then it will give a little bit of allowance of ULR as you go further away from the runway. But that it's not considered glare, because you would not effectively be glaring a pilot. You would just be confusing him. The whole purpose of that normative is to avoid pilots mistaking, when there's poor visibility, mistaking the apron lights as runway lights and then landing in the wrong place.
Okay.
And that level, that value can always be seen, let me see where, in the planning data. And this is ULR upward light ratio. And you always see it here in the first page.
Okay. And what about glare for, I don't know, reflection glare, for example, let's say from rainwater that's sitting on the floor? Is that considered in these calculations as well?
Right now, this calculation is done with the standard reflectance of the ground. But that is actually a very, very smart thing, because to ask, because it happened in the past in different airports where, for example, you have very concentrating hot spots on the ground, which they don't look good, but still they work when the ground is dry. When you actually add the water, the ground becomes a reflector. And so basically you get a direct bounce of the light onto your eyes. To simulate that, that's not very easy, because of course the reflectance of the ground is extremely variable, because it depends on the amount of water, if it's windy or not. But you can get a good estimate by going onto your ground element surface, and you change the RHO, which is the reflectance factor of the ground. Let's say that you go from a factor of 30 to a factor of 90, because the entire surface is covered in water. This will affect your glare rating. But sometimes it will actually give you the opposite result that you think, because your glare rating might decrease, because the contrast of the background then now becomes smaller, because the background has a higher luminance due to the higher reflection. Okay. Let's see, for example, I don't remember which one we did it on, the extended. See, now actually having a very reflective ground has lowered my GR values, because I have a very good optic here, which diffuses the light very well. So I didn't create any reflection hotspots on the ground. So, but instead, the whole area around it, since now it is very reflective, has a higher Candela's luminance. So my veiling contrast is smaller. I hope I was clear on this, but
yeah, makes sense. And there's lots more questions come in, but we'll come to them towards the end, because I know you need to move on to the sports example as well.
Yes. I just wanted to show you another scenario, just for a comparison. So we've taken the exact same configuration with the 18-meter masts, same number of floodlights, but instead of using our FH asymmetric optic, we're going to be using a symmetric optic. So something you would see probably in a sports field. So you already can see visually what the difference here is. We don't have a lamp sitting flat. We have a directional lens, which is pointed directly at areas on our apron. You can see that the light distribution is quite good. So it's something you could see in installation in the airport. But let's see what happens to our glare rating when we switch from asymmetrical to a symmetrical light source. What happens here is that we get very high, I mean, not very, but quite high values, at least above the normative requirements. Like even for ground crew, we get numbers up to 58. For pilots, we get even more than 60 glare, but we also see that the minimum values are actually lower than they were before with the FH optic. Because here we have minimums down to 34, but they're very similar to what we had. And actually, this is 30 meters. The 34 is actually lower than the minimum we had with our Titan luminaires at 18 meters. This will show you why the symmetric optics are not a good fit for this type of application. So you go from a spot here, and you will walk just a few meters, and your glare rating will jump up by 20 in the span of about 9 meters. What happens is that you create hotspots. So if you're sitting in a certain position, you get hit with the highest peak of candelas per kilo lumen by one luminaire, which is going to glare you a lot. Then you move slightly, you fall out of the peak, and you're in a pretty comfortable zone. Then you move again one step, you fall into the peak of the next luminaire. So this is always something that should be looked at carefully, especially when dealing with symmetric optics. Always increase the density of the GR calculation points, as you will see major differences from points which are very close to each other. Sometimes, of course, due to the geometrics of an area, you're left with no other options than using symmetric. So in that case, what you'll be able to do to mitigate the glare as much as you can is you identify, for example, here the central area of the fuselage where I know that the pilot will sit at every spot while moving, and you always try to avoid having direct beams going onto this line. So for example, here, in order to reduce the value, we would try to avoid luminaires crossing the beams on top of the plane. So we'll try to keep them in their area as much as we can. But of course, the result is always going to be that I'm moving the glare somewhere else. But sometimes you're left with no choices. So if you don't have any immediate questions on this scenario, I would like to proceed on to the sports one.
Paolo, we do, but we'll come back to them at the end as we go through the sports.
Oh, yeah,
so
it's already pretty late.
We've already got your questions come in, guys. So hold fire, and we'll get to them once we've gone through the next scenario.
Yeah, we'll answer everything afterwards if we don't have the time. So let me jump back and open the other simulation here. Here we're going to be looking at our standard football pitch, 100 by 60 meters. And here we're going to show you the impact of the designer of the glare rating of an installation. So what we're going to show you is the same exact field with the same exact mast, the same exact luminaires, and the very similar results on the ground in terms of lux and uniformity. But by using two different aiming methods, we'll show you this first simulation with extremely high glare, and then a perfectly compliant one. So let's open both of them up and check. We will start from the results and work our way back. So we have the first, it's high glare. We have placed observers equally in a grid across all the field. We have placed 50 observers here. We can see that the results are not terrible, but we have a lot of points which exceed the 50 GR rating. I think the highest is 53, but we're always playing on the edge. Then we go on to our second option. Again, this is with exactly the same luminaires, same number, same height, same everything. And we see that we have no points going above 50. And actually, we're always in the lower 40s in most of the points. How is that? The main difference here is played by tilting. In this case here, we have a luminaire which uses mechanical shielding, like we've seen in the presentation. Let's see a little bit of the numbers. We have 6 masts around the field. This is a symmetrical optic, which you can see here. It's slightly asymmetrical because it's again affected by the mechanical shielding. And in this first scenario, we see that the average tilt is between 71 and 73 degrees. That means that, maybe you can see it better in 3D. So basically my luminaires are pointing the opposite side of the field, exposing the light source a lot in all this area of the field. Then I go on to the lower glare simulation, check the beam angles. You can see that this orientation is always in the neighborhood of 60 degrees, which is just a 10 degrees tilt difference. But this means that when I go onto my field and I'm sitting in the opposite side of the field in respect to the mast, I don't see the light source. The light source is hidden from me. And this will greatly reduce your glare rating values. So again, the glare rating is something which is always partly due to the producer making a light which is going to have lower veiling luminances, but half of the blame of the glare is on the designer itself. So let me jump back onto the simulation. Sorry, to the presentation.
Paolo, quick question with regards from the sports lighting, because there was a question that came earlier on with regards to the shields that are used on those lights. Now, do the shields affect the illuminance when you start to obviously work around mitigating glare? How much effect does that shield have on the actual illuminance on the pitch?
Well, of course, the shielding has effects on the luminance. Actually, let me go back here and we can look at it. Of course, I mean, this is going to hide your light source, but wherever the light source is hidden, that means that no light from that source is hitting that spot. So it's going to change, it's going to affect a lot the shape of our photometric emission. It also, of course, going to reduce the total lumen output of the luminaire because you're effectively shielding light. But if they're well made, and for example, the ones we use are coated with a highly reflective aluminum surface, they can actually improve the performance of the luminaire compared with the use of solely a symmetrical optic. Because the light that is reflected onto the ground by the visors, it's light that was going to end up towards the sky anyway. So not only I avoid ULR, I reduce GR, but I also reflect back onto the ground some light that was going to be wasted. Of course, the shielding is something you have to consider doing the design. So it's not something that, okay, I do a lighting design, oh, it's glary, let me put a shield up. The photometric files that we use have been made with shielding installed on the luminaire. So what you see on the DIAlux is what will be in real life.
Okay, great, thank you. We're going to quickly do another poll before we answer the rest of the questions. So it should pop up on your screen now. And bearing in mind that we do still have questions to answer, we just want to understand essentially where people are at currently with regards to their understanding of mitigating glare. So in general, has this session so far helped you understand how to mitigate glare during the design phase? And I suppose we're after an understanding of it has, and actually, you know, it was just confirming information that you had, or yes, but in fact, you really would like some more information on this topic, and it's something that we should probably reach out and have a conversation with you on, or do future sessions. So for us, we just want to get a little bit of an understanding of whether the session has been useful, and obviously with the Q&A still to come, whether it would be something that you would feel adds value and we should do a session, or obviously reach out to you separately. So let's just share these results. It's more something for us internally to understand instead of something for the group. So I'll give everyone just another 5 seconds and then we'll close this down. Okay, great stuff. So good news is it has been of value to pretty much 95% of the audience. So really appreciate that. So now we're just going to get back into the Q&As that we have, because there's quite a few questions that have come in here. So there was a question around the process with the airport aprons and whether the same evaluation that you've just used to do the calculations on glare, whether you could use the same evaluation for approaching pilots. And I assume the question is based on pilots who are obviously coming into in the taxiway to use the apron.
Yes, of course. Let's say that, because I saw also another question which is very similar, which is evaluation of the glare for moving aircraft, for example, a landing aircraft. The methodology will not change, because this calculation shows you the glare at a given point, whether the observer is moving or not will not change. So you can add as many glare rating points along the track along the runway or the taxiway, and you'll be able to evaluate the glare at each of these given points. You can make very detailed models. But what I say is, if you calculating the glare onto the runway, you have to build out the scene for the whole airport, because otherwise you just lose the whole purpose of it.
And that actually leads really nicely onto the next question, which is whether there are any general background veiling luminance factors that can be applied for a typical terminal building or a city's ambient light.
Not that I'm aware of. I don't know how to like simulate a standard background, but it just might be me not aware of it.
Okay.
What I tend to do, if I don't know exactly what the background is again, like I showed before, just don't consider it. Like, focus just on the task area.
Okay.
But I'll do some research on it. That is an interesting question. If I find something, I'll share it.
Yeah, and with all this, guys, we've got your information. So if something like that we do find, then we can reach out to you directly post the session and send this information out. Or of course, you can contact us and ask more questions. There was a question came in regarding maritime and ports, for example, and it was a question which I think is going to be reasonably easier. But do we have sections such as the apron that you've got to help simulate glare? And I know the answer is yes, we do have those scenarios and we can share them post.
Yes, we do have, of course. I mean, we don't have anything ready right now, but it's something we would evaluate into a lighting project, is to put GR ratings, especially if we know that it's somewhere where machinery is moving freely around the terminals. We always want to avoid, of course, having glare hotspots. So because we have drivers, the drivers of strato carriers or the reach stackers are just like aircraft pilots.
And staying on ports, interestingly, a great question has come in as well, because there are some restrictions in ports with regards to glare and lighting. For example, for wildlife, turtles is a great example. Is there a section in DIAlux, or is there something that we've done previously where we can check those regulations and help simulate that scenario?
Yeah, that's similar. The scenario can be simulated easily on DIAlux, but even though it is defined as glare, sometimes what it actually is light spill. So usually these environmental agencies, depends from which country you're talking about, they try to restrict the light spillage over wildlife area. So basically it just goes down to a lux calculation into a given target area. Some other environmental agencies, they give a limit of light spill of a certain spectrum, which is usually the white and blue light. So sometimes they request lighting schemes to be done with all purple, all red and orange lighting, especially for the turtles, which will have to use a very specific type of luminaires in order to do so. Okay,
great. You actually did touch on this point in the session, but I'll ask you to repeat it just to confirm the answer. Obviously, different aircraft stands have different aircraft types. So the question is, how can you calculate glare for the different cockpit heights? And you mentioned that it's all about understanding the type of aircrafts that are using the type of apron, and therefore putting that into your calculation once you know what stand is being used for.
Well, I mean, generally the rule is, okay, if you're calculating the glare on a taxiway, you don't want to place GR observers at every height, starting from Cessna to the A380. What you do is usually you place at the lowest, the middle, and the highest level, because you will see a trend going up and down. So you generally literally just Google the cockpit height of the highest plane that can land there and the lower plane, and you place two observers at the two limits.
Okay, great. If the luminaire is tilted closer to the light source, will this affect the lighting uniformity?
Oh, okay. So if the tilt is reduced, oh yeah, of course, yeah. tilting the luminaires will move your light beam closer or further away to the pole. If this is referred to the sports scenario, actually, no, it didn't. It actually improved the uniformity. It all comes down to what photometric you're using looks like. So some photometrics will require a higher tilt, some will work perfectly with lower tilt, especially if you're using asymmetric, that is made to be installed flat to the ground. So zero tilt will give you good uniformity. But yeah, generally the concept, it will affect the uniformity.
Great. So we're actually going to bring the session to a close now. It's 1 minute past 3, so we're just a minute past the hour. Anybody who asked any questions, all the questions that we did answer live, we will fill in the Q&A response and we'll be able to post it on our knowledge hub on midstreamlighting.com, and we'll make sure that this information is passed back in the follow-up email so that you know where to look to find it. Paolo, if you could just click forward a couple of slides for me.
Oh, yes.
So the next session next week is all based around the basics of lighting design for sports stadiums and facilities. So if you've joined a previous session where we've done these lighting designs for maritime and aviation, this will be a fantastic session for you to join, because we'll be going through tips and tricks based around stadiums and facilities. It's going to be brought to you by Marco Cavallotti. So a different presenter next week. It's going to be a really fantastic session. So we're looking forward to that. And of course, there's going to be a survey that will pop up post the session. It's 4 questions. It will literally take you 30 seconds to fill in. Please respond. It helps us plan and work on our next sessions for you. So that is everything for today. Thank you so much for joining. Sorry, we're a couple of minutes over. Paolo, once again, fantastic session. Really appreciate all your...
Thank you, everybody, for joining.
Thank you as well, everybody, for joining. Hope you're all safe and well. And we look forward to bringing you another session next week. Enjoy the rest of your day. And that's bye from us.
Bye-bye.